Okay, so here's our satellite. It's going in orbit. We want to know what the velocity is. So we only have one force. That's the force of gravity. That's what keeps us in the circle. Right? So we're going to set this equal to ma. What's our equation for, or what is A? What kind of A is this? Centripetal A. That's what keeps us in the circle, right? Centripetal A. What m is this? Is this the mass of the Earth or the mass of the satellite? Satellite. So just remember, whatever, when you have an ma, whatever mass is paired up with the acceleration, whatever's going in the circle, that's the mass that you're going to use. So obviously the satellite's the thing going in the circle. So if we were close to the surface of the Earth in most of the last unit, or actually all of the last unit, and all of this unit until Friday, what did we use for Fg? mg, right, it's the weight, mg. However, we're not close to the surface anymore, right? So what are we going to use for Fg here? Okay, the full equation for gravity, which is big G m over d squared ms. Let's break down our AC. What's our equation for AC? We have two m's here. Let's clarify the two m's. What are the two m's?
Earth and satellite.
Earth and satellite, good. So remember, it's the between the two masses, mass of the satellite, mass of the Earth. Okay. Alright, so maybe you can see a cancellation. What's one cancellation we can make? Mass of the satellite, right? So it doesn't matter when you're putting things into orbit, it doesn't matter what their masses are. What do we mean by d? What distance is that? Okay, from the center to the center. Yeah, so that's what we mean by d here. So I'm going to call this d total, just so we understand. That's the distance from center to center, right? Center of the satellite to the center of the Earth. What do we mean by the radius? So this would be the circle, the center, the radius of our circle, right? Well, what's the relationship between the distance from the center to center and the radius of our circle? They're the same. Good. So notice here that the radius of our circle that it's making, it's a radius based on the center of the Earth to the center of the satellite. So these are the same things. So d total, center to center, that's also the r here that we have down here. So these two things are exactly the same. So we can cancel out one of these, right? We can cancel out one r and one d here. Those are two things. Those two are the same. So let's see what we're left with. G me over d, and remember this is d total, so I'll just clarify, equals v squared. So at this point we can go ahead and start solving for what we need to solve our numbers. This is kind of the derivation of the velocity, how we would figure it out. We are given the mass of the Earth. You guys wrote it down somewhere, right? And the radius of the Earth. I have it on the board, but it's covered up, so I'll just look for you. Okay, so let's just write it up somewhere. So radius of the Earth is, how much is it? And the mass of the Earth, 597. Alright, so make sure d totals. This is where most people make a simple mistake here. This is our d total. I would suggest just kind of doing your d total on the side. D total is center to center. So that's going to be the radius of the Earth plus the distance above the Earth. So make sure you add in that distance. That does become a factor at this point. Once you're high enough, you know, even if you're 1 kilometer, that's still probably not going to be high enough. But 800 kilometers, that's definitely high enough to affect it. So the radius of the Earth is 638 times 10 to the 6th. The distance above, you do have to convert this, 800 kilometers. Kilo is 1,000, so 800,000. So 6.38 times 10 to the 6 plus the 800,000 meters additional that we are above. So what's our total height then, above from center to center? 7.18? 10 to the 6th. Okay, make sure you guys are, you know, plugging this in. Make sure you're getting the same thing. A lot of this section is the mistakes come in the calculator, punching it in. Okay, so that's our d total. Once you have your d total, I usually like to put it off to the side because you'll use it kind of throughout. At this point, though, I think we're ready to go ahead and solve. So again, let's all of you, why don't you try to plug this in yourself? A lot of people mess up on this calculation. Let's make sure we can all get the same answers. Again, try to use the shortcut, the little double E button. And again, make sure that you're using that total height, 7.18 times 10 to the 6. And then don't forget to square root. Once you get that number, don't forget to square root it out. Anyone get the speed yet? 7,145. 445. 447. All right, good. Or about 7450. If we went to 3 digits, 7450. Don't forget to square root, okay? Okay, so that's kind of the new thing for today, how we would figure that out. I did ask you a second question, which was the period, but you should all know how to find the time. How do we find the time of a circle if we know the velocity? V equals d over t. What do we use for a d? Circumference. What are we going to use for a radius? Do we use the radius of the Earth? Do we use the distance above the Earth? Or do we use the total distance? Total distance. You're always going to use the total distance, center to center. Someone got the time yet? It's like 6,000-ish. 67? Maybe just for fun, can you tell me how many hours that is? How do we find how many hours? Divide by 60 to give us minutes, and then divide by 60 to give us hours. 60 twice.